Hey guys, welcome to the podcast where I'm going to talk about our linear sequences that we've been working with in class with tables and seeing sequences as lists. And then I'm going to connect those concepts to a graph and the equations. Because right now, all that we're doing is we're trying to explain linear patterns and writing a rule that describes the pattern. So I'm going to make some connections that help us jump to really just linear thought, meaning past the sequence conversation and concepts to letting our terms be whatever number we want. So if you want to follow along with this video, with the GeoGebra that I'll be using in the video here, then go to my website, which is this link here. So you could pause the video, open up your browser. Again, you should have your browser open, but go to my website here and then follow the instructions. If you don't want to, I'm not saying it's mandatory, but it's good to help you learn. If you don't want to, just fast forward to the video where I'm past the video instructions. So if you do want to, though, pause your video, go to this website, and then restart the video, and I will help you move on. So after you pause the video and you go to my website, so you go to the sites.google.com/site/rbowersmath. Oh, and by the way, in my classroom here, notice I got the nice classroom. Above my smartboard when you're in class, you're going to need to go to my website anyways. So make sure you know where it's at in my room when you get to class. So don't ask me, hey, Mr. Bowers, what's your website? Because it is right in front of you above the smartboard. So just wanted to point that out to you. Now, to download GeoGebra real quick, I have a couple things here. Get GeoGebra, so you're going to go to the GeoGebra link. So when you click on that, a new tab opens. You're going to the GeoGebra webpage, and then you're going to click download. And then depending on what type of machine you have, if you want to download it on a tablet, you can. The apps aren't the greatest yet for GeoGebra. They're new and they're not fully functional. But if you want to put this on your computer at home, just click the Windows, or if you have a Mac, you click the Mac link. And then when you click these, it's just going to go through the, do you want to save the file? Yes. And then when it's done saving, just go through the downloader, or excuse me, the installer, and then you'll have GeoGebra on your computer. Now, once you get GeoGebra on your computer, back on my website, if you click on the Integrated Math 1 link, at the bottom of this page right now is linear pattern generator with input evaluation. So you would just click the download arrow, and I believe you can open it right through this dialog box here, assuming you have GeoGebra installed now. If you can't, you're going to have to save the file and then open the file up through GeoGebra, which isn't hard. It's just a different route to open your file. So if you can get that, this will have this GeoGebra app here that I'm going to be using in my lesson that you can work along with if you want to. Okay, let's go ahead and talk math now. So there are two types of sequences that we've seen so far. They've been in list form, like this example, -2, 0, 2, 4, 6, 8. And then the other way is seeing it through a table, seeing linear patterns through a table, which it's not obvious to see that this is linear. The nice thing about lists is we can see, okay, we're just adding 2 to get from term to term. So this is a nice linear pattern because we have that constant difference of +2. Okay, so what we've been doing so far in class is identifying what your first term is and what your difference is, which we just said was add 2, and that's what we do to to get from term to term. So our general rule that we write is our first term plus our difference times n or x minus 1. And what that equals, what we get when we put in any term number, say like the 10th term. So if I let x be 10, this will tell me what the 10th term would be. So we've been calling this the nth term. So in this example, n would be 10. We would find the 10th term, which in this rule would be 10 minus 1 is 9, if we were to find the 10th term. 2 times 9 is 18, and 18 minus 2 would give us 16. So we know that the 10th term of this sequence would be 16, okay? So writing the rule is very important to be able to do that, okay? And then also finding specific term values. Now, one thing that I want to do is I want to connect to you guys the simplified version of this equation here. So I'm going to erase all this real quick. And let's take a look at this sequence again. I'm going to write the rule that I just had here. We said that the nth term is equal to the first term plus our difference times n minus 1. And sorry guys, I'm writing with my mouse, so it might look like a kindergartner's writing. But here's our rule that we've written. Now in class, I've had you guys simplify these rules, and to do that, we just take our difference and we multiply it into the quantity here. So if we do that, notice nothing's affecting our negative 2, so this is still the nth term. It's negative 2 plus now 2 times n is 2 n's, and 2 times a negative 1 is negative 2. So now when we combine like terms like negative 2 plus negative 2, that gives us negative 4. So our rule now becomes 2n minus 4. So what I want us to get through this video is that these two expressions, though they look different, are what we call equivalent. They're the same thing, just they have a different look to them, right? So how can we argue that they're the same thing? How can we make sense of that? So to do that, I'm going to use the graph to help us understand what's going on here, okay? So first of all, I'm going to graph this sequence. Now, if you followed the video and you download that GeoGebra app, then this is what you're opening here. If you didn't, if you didn't want to follow along, this is your first time seeing this in the video. What this app allows us to do is we can choose numbers of terms in a sequence, right? So maybe I want 3 terms in my sequence, or 4, or 6, or 8, okay? So we can change the number of terms that we want to look at. We can also change the first term of the pattern. So notice right now I have one term showing in the video here. So there's 1 point. This is my first term. So since our inputs, like when we talk tables or whatnot, um, is like our first term back in the sequence here, then this is the same thing as our first term. So really, if I make a table here real quick, then wouldn't this be like our first term, second term, third term, fourth term, fifth term, sixth term? Remember that 10th term we found, I believe, was like 16, right? So if we were to go all the way out to our 10th term, we would have 16 in our list. Okay, so these become our inputs when we look at tables, right? Tables, our input column, you know, those are our term numbers. And when we graph, we need to understand that our input column is our horizontal axis. So when we look at graphs and we look at sequences like -2, 0, 2, 4, 6, 8, and so forth, then this first term, notice its x coordinate or its term number coordinate will be 1. So here's our first term. Okay, so now I'm going to change our first term to look like our sequence. So notice as I move the first term, this point is just jumping the output on the y-axis here. It's telling us right now I have my first term set to 2. So notice our y-axis here is at 2. But we want our first term to be -2. So I'm going to type in here, or you can just move the slider to -2. So now I'm changing my first term now is at -2. So we got our first term is -2. Okay, and then the difference between terms was a +2, and I have that set here, so I'm going to leave it there. So now notice our second term in our sequence, we went from -2, 0, 2, 4, 6, 8. So when I hit my second, when I look at 2 terms, notice now the second term, that's what the x-axis is telling us, or x-coordinate of the point. That's what these crosshairs show us. First term, second term. Notice its y-coordinate, or its output, is 0. So we have -2, 0. The third term is 2, right? The fourth term would be 4. Fifth term would be 6, and so forth. Remember, we found the 10th term, too. We said the 10th term was 16. So if I actually plot out to the 10th term, here's all 10 terms in our sequence, and notice the 10th term, which is its x-coordinate here is the 10th term. Notice it has a value of 16. There's that 10th term that we found. Okay? So now, what's cool about this app is if we click this evaluate for input value, then right now I'm going to evaluate for 1. So what it's saying is if you're inputting a 1, so our first term, then we get out at -2. And that's really what this crosshair, and notice we have a purple crosshair to highlight that point. We're putting in a 1, we're getting out a -2. Or we're showing our first term is -2 if we think sequences. Now, as I input maybe 2, notice what this does here is it shows us when we start at our first term, we're going to increase the term value by 1. So we're going from 1 to 2. And notice our output, or the term value, is now going up in this case from -2 to 0, so it's going up 2, right? So as we increase 1 on the term number, notice our output, or the difference here, is going up 2, which that 2 is our difference that we chose, right? So now, if I want to evaluate 3 to get to the third term, remember, this is what our rule, the f plus our d times n minus 1 is showing us. From our first term, we increase a difference of 1. So from this -2, our difference is 2. So isn't -2 plus 2 0? So we added 2 to our first term of -2 to get to our second term 0. Our third term then, in terms of our first term, says that we started our first term of -2. To get to the third term, notice we're adding our difference twice, right? 1 less than the term number. So really what we're adding from -2 is 2 once and then 2 again, and notice that is our third term. So our fourth term, we would start at our first term, add our difference once, twice, 3 times, and our fourth term then is 4, right? Okay, so this is really showing graphically what our rule is saying. Here's our first term, and the red arrows here are our differences that we're adding. So to get to the fourth term, we're adding our difference to the first term value 1, 2, 3 times. So 3 times 2, since they have a length of 2, is 6. So we're really adding a value of 6 to our first term here, okay, which gets us up to 4. All right, now when we simplify the equation here. So this is what we're representing. Here's our first term of -2, right? That's where the pattern starts. And then we're adding our difference of 2. That's what each of these red little arrows are showing us, that we're increasing by 2. That's adding our difference. N minus 1 times. So again, fourth term, we add our difference. You can see the red arrows are 3 times, 1 less than the term number. Okay? So this is actually visualizing our rule pretty well. Okay, so now what I want to do is I want to relate to this pattern our simplified form. These are equivalent, right? We've just simplified this formula, this rule, to look like 2n minus 4. But let's think about what this means. 2n minus 4. Okay, so let's look at our rule here. 2n minus 4. So it looks like our first term is -2, and if I go back down to the first term, oops. Okay, here's our first term. Now, -4, notice that output is down here, right? But if we look at our pattern here, if we think backwards, instead of increasing our term number by 1 and going and adding 2 to get to the next term, what if we work backwards? What if we decreased our term number by 1, if we decreased it by 1? So going from the first term to the 0th term, we would, instead of adding 2 to the value, wouldn't we subtract 2? So actually, if I put in a 0, what I want to evaluate, notice now, this point of -4 is what we call the y-intercept here, right? So what the simplified rule is actually doing is it's taking our difference of 2. That's what we're adding as we increase n every time. We're adding a value of 2. But now, instead of starting at our first term of -2, it's actually starting at the 0th term, right? It's starting at the 0th term. So now when we apply this rule here, we're saying the 0th term is -4 of this sequence, which it is, right? Because here's our first term at -2. Working backwards, we're going to subtract 2 from that value, and we get to -4. So this is saying that start at your 0th term, and now we can start applying our difference. So we're adding 2 every time. And remember, repeat addition is just multiplication. So this rule that we write here is actually the same thing as this rule. It's just, instead of starting at the first term, we're actually starting at the 0th term. And that's why they look a little different. But still, if I wanted to find the 25th term, for instance, I'd still let n be 25, because that is the term number I want to solve for. Now we just evaluate this form, which is a little easier than this form that we're using. So 2 times 25 is 50, and 50 minus 4, right? 50 minus 4 is 46. So we know that in this sequence here, the 25th term is 46. And let's check it to see if we're right. So what I'm going to do is let's evaluate for the 25th term. And if we do that, notice we're inputting a 25 and our output is 26. Okay, so we'll change our terms that we see here to 25. Notice So first way that we wrote the rule is saying start at your first term, and now we're going to start applying our difference. Since we're going to the 25th term, we would apply our difference 24 times. But now if we simplified the rule that we evaluated, we're actually starting at the 0th term. And notice if we start at the 0th term, all right, so if we actually go down 2 and then to the left one, and we start here, now we actually apply our difference one extra time. And since the original rule, this rule that we wrote right here, starts at the first term, we apply our difference one less than the term number. Since now this rule, which is simplified, is starting at the 0th term, that means we have to add one more difference that we apply. Hence the reason that we don't have a minus 1 in here. Okay? So 2n minus 4 is the same thing as this negative 2 plus 2 times n minus 1, just by simplifying it with algebra. But what this rule is doing now, starting at the first term, we're starting at the 0th term. Okay? The next example that I want to show you too is through a table and how we can get to our rule and then our simplified rule. So this is what we've been doing in our homework so far, is to identify the first term and our difference. Now, let's plot these points here and show that it's linear. So we can use a graph to show that this is linear. What I'm going to do, if you're following along, is on my GeoGebra app here, I'm just going to go to File, New Window. So now I have a new window that I'm going to play with here, because what I have in my example is some inputs and some outputs. So I'm going to actually put this table in GeoGebra real quick, and then I'm going to graph these points. Okay, so negative 218 is my first pair of points here of my term number and term value. So if I go to View and I click Spreadsheet in GeoGebra, it creates my little spreadsheet here. So this first A column, this is going to be my term number, so like negative 2. And then we said the negative second term, negative 2 is 18, right? So now I'm going to put in all my pairs here. If the fourth term is 0, and I noticed also when I was looking, my third term it was 3, okay? And then my negative third term was 21. So if I have my negative third term, we get out of 21. So those are the only points that I have in the table. Now, if I click with my left mouse button, A1, and I drag so that I highlight all my points here, then what I can actually do with GeoGebra is in this third toolbox here where it says Create List, if I click the down arrow, I can actually create a list of points. So if I click that option, it tells me here's the name of the list, and I really don't care right now what the name of the list is, and this is what it's going to plot. The negative second term is 18, the fourth term is 0, the third term is 3, and the negative third term is 21. So when I hit create, notice it gives me my points there. I can't see a whole lot, so what I'm going to do is make sure I have my move tool selected, and I'm just going to click in my graphics window. That's this main window here. Notice my tools go back to my normal tools. And now if I go to Move Graphics View, the little compass looking thing here, it's a little hand, and as I click my left button and hold it, notice it grabs a little fist like it's grabbing the screen, and then I can drag it around. Okay, so I want to make sure that I can see my data here. Notice we put in some negative values, and we're getting out like 18, 21, but my y-axis is only going up to 7. So two ways to go about that. The first way is if you have your Move Graphics tool selected, if you hover over an axis like the y-axis, notice my hand turns into arrows. So if I click and I move, I can actually change my scale. Right? So now I can see all my points. Notice I only had 4 points in the table here. So now here are my 4 points here. And that looks nice and linear. So remember the rule that we have to write, though, needs our first term, which means we need to find out what the first term is of our sequence, right, to fit this pattern here. Well, how can we do that? Well, I know my, see, I got consecutive terms, don't I? Like my third term, we got out of 3, and my fourth term, we got out of 0. So basically, what it's saying is, as I go from 3 to 4, don't I have to subtract, in this case, to go from 3 to 4, I have to subtract 3, right? That's our difference, isn't it? And if I gave you like the negative third, negative second term, our negative third term, which is this D point here, notice it has a value of 21, and our negative second term has a value of 18, and that makes sense because those are consecutive, and that means that to go to this term here, I would also have to subtract 3, right, as I increase my term number by 1. So there's my difference. I don't have the first term here. I'm going to turn my grid on so I can kind of see a nice grid here. So I'm going to grab my move tool. I'm just going to click on the white here, and notice now under graphics, as long as this arrow is pointing down, I can show my grid. Okay, so now what I'm going to do is, if I know my third term, I don't know if you can hear that. There's an announcement in my classroom. I know my third term, so basically to get to my second term, don't I just have to follow this pattern, but I'm working backwards now. So if I'm sitting here at 3 on my third term, then to get to my second term, I would have to add 3, right? Which actually puts me at 6. So then to get to my first term, I would decrease my value by 1, and I would add another 3, which actually gets me to 9. So there's my first term of 9. Right? So my first term I know is 9. So now I got my rule because I know my difference also. My rule would be my first term plus my difference times x minus 1. Now, if I go ahead and clean this up here and distribute the negative 3 through, 9 plus, we get negative 3x. Remember when we distribute negative 3 times negative 1, this is a positive 3 now because the negative times the negative is positive 3. So now when I combine my like terms, I get negative 3x because there's nothing to combine with the x term plus 9 plus 3, which is really 12. And think about it. If this was my 0th term like I used in my last example, because I'm going back one term, then don't I decrease from my first term? I'm going to decrease by one value. So here's my 0th term. And so from 9, I have to increase another 3, which is 12. And notice that's our value here. So based off of a table, even though I don't have my first term, 0th term, but as long as I can find my difference and I know some term values, I can get to what's important, whether it's the first term, which we use with this rule, or the 0th term, which we use for this rule. Okay? So as far as graphs are concerned, I want us to be able to start looking at graphs and understanding what's going on as far as term number and term value, right? So when we start looking at sequences, we can start understanding linear patterns, okay? So thank you for watching the video. I apologize for the length. I'll try not to keep them this long. Um, I'll see you in class tomorrow. Thanks.